One thing that's an interesting question to ask is that since your digestive system is there to digest things like vegetables and meat, it's a little bit awkward to remember that your own body is made of the same types of macromolecules that you're trying to digest in your digestive system. So this is a system built to tear apart the very thing it's made of. So the question is, how does the digestive system protect itself from itself? And there are a few ways it does that. One is that in your stomach especially, there is an enzyme that is really good at digesting, breaking apart proteins. And that enzyme is pepsin. And if pepsin were in your stomach all the time, then your stomach would be digesting itself all the time. So instead of making pepsin, you make pepsinogen. Pepsinogen is like pepsin, but just with one little bit that's easy to break off. I'm going to put in bit here. I'll be really technical. Easy to break off in the presence of an acid. When an acid comes along, like the hydrochloric acid in your gastric juice, your stomach juice, that bit gets broken off and suddenly you have pepsin. Gen means can make or create. We see that in glycogen. We use it to make glucose. Whenever we need a piece of glucose, we break it off of a glycogen. Same thing with pepsinogen. It makes pepsin. When we need pepsin, we just break off that bit and we get pepsin. That only happens when it's acidic. And your stomach is only acidic when it's making gastric juice. So you don't make gastric juice, which is a terrible, terrible product. If you see it at the store, don't buy it. It's disgusting. You don't make gastric juice until your stomach has food in it. Well, most of the time, okay? Let's just say that's true. It's not really true. But one of the main clues here for your stomach to start making it is that your stomach stretches when your stomach has food in it. There must be some kind of receptor in there that senses that stretch. And, well, there are, and you'll learn more about them in Bio 30. And when your stomach stretches, then you start to release a hormone called gastrin, which I'll talk more about in a minute here. And that will start to make that gastric juice. You also have, in your digestive system, lots of neutralizing things like bicarbonate ions. They are a buffer. Bicarbonate is the same stuff that's in baking soda, sodium bicarbonate. And HCO3 negative will take an acid or a base, either way, and bring them both towards a pH of around 8. So not exactly 8, but around 8, which is pretty close to neutral. Remember, for your scale, going up to 14, 7 is neutral. Anything over here is acidic. So between 0 and 7 is acidic. Higher than 7 is basic. But anything kind of close to 7 is pretty close to neutral. And most of your digestive system is pretty close to neutral. The pH in your mouth is around 7, unless you're drinking lemon juice or coffee or something. The pH stays pretty neutral, In your stomach, here the pH gets as low as 2, or sometimes even 1. That's really acidic. Hydrochloric acid is a very strong acid. But your pancreas is one of your accessory organs. It's the greatest accessory organ. Pan meaning all, and kreos meaning create. It makes all. It makes enzymes to digest all of your types of macromolecules, plus bicarbonate ions that neutralize. They come out here through the common duct into the duodenum. They neutralize all of the acid from the chyme in your stomach right away. And remember, neutralizing acids or bases creates heat. Your duodenum is not a very friendly place to be. It doesn't have so many villi because it's a war zone in there. But those bicarbonate ions are buffers. They bring the pH to around 8. Well, it would still be pretty low here, maybe 3. 8 by the time it's maybe here. And the pH stays around 8 all the way to the end. At the very end, we could call it 7. We could call it neutral again. It's pretty close to neutral by that point. At this point in here, it might be 8 or it might be 9, but really close to neutral, just a tiny bit alkaline. Your stomach has a layer of mucus, and that layer of mucus is protective. It's not a very good protection. If you were to put your hand into a bucket of acid, you wouldn't want your only protection to be snot, but it's better than nothing. So that mucus layer is on the epithelium of your stomach, and that word means the lining, the cells that are lining your stomach. Remember, the inside of your stomach or your intestines would be called the lumen. This is the epithelium, which is the lining of them. And one thing to focus on as you're studying is the gastrin or secretin or CCK hormonal control of your digestive processes. So this image here is looking at your stomach. This is the cells of your stomach wall. This is the gooey mucus layer on top of them that's secreted by those cells. So they make this goop. This is what's inside your stomach. And out here are the capillaries. This is the blood that is providing nutrients to your stomach cells. So your stomach cells make mucus, which makes a very thin and not very protective layer, but better than nothing. Your stomach cells also make some bicarbonate ions by themselves. And also, they don't make acid. So hydrochloric acid is where all these H pluses are coming from. They don't make acid until your stomach is stretched out with food, until there's enough food to mix with it. So for the hormonal control of your digestive processes, you eat some food. Your stomach stretches. As it stretches, probably there's food in there. The hormone, gastrin, is released. And hormones go through your blood, all through your body, but they only have certain receptors that work for them. And those receptors here are in the stomach. So when the receptors in the stomach get wind of this gastrin that's been released, once it comes there, then your stomach will start, this gastrin starts your stomach to secrete gastric juice. Gastric juice has hydrochloric acid, it has mucus, it has some salt in it, it has some water in it, of course. Lots of stuff in gastric juice. Your stomach will churn, and it'll keep adding more gastric juice until it senses, by sensing pH, that the pH is dropping too fast, which means that it's not mixing with the food anymore. So once that happens, as your stomach is churning, of course, your low pH in your stomach is going to activate that pepsin from pepsinogen. As you're churning and churning and churning, eventually your stomach pH will drop way down. At that point, you'll stop making gastrin and start with another process, which is making secretin and CCK. CCK stands for cholecystokinin, and I don't think anybody has ever spelled that correctly in a test for me. Maybe they did and I didn't notice. That'd be a shame. Anyway, you can be fine with CCK for cholecystokinin. These two have slightly different jobs, but we're going to treat them as being the same for now. Once you release the hormones, secretin and CCK, cholecystokinin, that'll stop your stomach from churning. So gastrin starts your stomach from churning. No gastrin should be a stop signal, but secretin and CCK are an extra stop signal. This little symbol here means inhibits or stops. And they will also tell your pancreas to make bicarbonate ions to neutralize that stomach acid, and to make the pancreatic juice that has all the digestive enzymes to digest all 4 types of macromolecule. It'll also tell your gallbladder to do a little squeeze and squeeze out some of the bile that your liver made. Remember, your liver makes the bile, your gallbladder stores it, and when you're ready for it, it gets squeezed into your duodenum through the same duct that your pancreas takes. There's more bile released if you have a really fatty meal, which is an interesting thing because bile is an emulsifier for lipids. That's helpful. So it kind of has a dual purpose there. So these are ways that your body protects itself from itself while it's digesting food. I hope this helps with your studies. And if you have any questions, you know how to find me.